Okay, let's start with um, day 9? Yeah, I think it's day 9. Okay, in an isosceles trapezoid, the length of each leg is 3, the length of each diagonal is 7, and the length of the shorter base is 5. Find the length of the longer base. Okay, so it's isosceles, that means, or at least in a triangle, that means that two of the sides are the same. So in a trapezoid, the length of each leg, so that means the legs are the same. Let's just draw this out. The length of each leg is 3. The length of each diagonal. Okay, wait, this is 5. Oh, this is 5. And I need to find the length of this. And the length of each diagonal is 7. I could draw a better version of this. Wait, give me a second. Question mark. Okay. Each diagonal is 7. Huh. How do I go about this? Wait, first off, guys, I just need to redo this. Do, bam, 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 bam. So this is 7. Huh. Um, I'm starting to see, are these two similar isosceles triangles? So this one here and this one here, is that, wait, let's see. So on the base there is this angle and this angle. And on this one there is, no, those are not the same. Okay. Um, hmm. What if this is not 90 degrees, so we can't use any sine, cosine, whatever. What if I also draw this? Does that give me anything? Well, I know these are two similar triangles, but that's not really helpful. This... Is this a similar triangle? Bam, 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 bam. If these bisect, are those the same? These two are definitely the same. This and this I don't think are the same. Is there any way to find that, though? There's probably a specific theorem that I don't know. So I'm going to find if, what the lengths are. Do I know that these bisect? That this line bisects this line? Let's think. If I have a trapezoid like this, and draw that, does that bisect that? I don't think that bisects. I should use the line tool for now. Can I? Is there a line tool? No. It's not a line tool. Line tool. Okay. So, if I draw a trapezoid, I need those to be the same. So if I draw a trapezoid, and that copy, not what I meant to do there. Let's select this, let's take this, let's copy, let's paste it, let's reflect it horizontally. So that means that those are the same length, and now I'll get this line from here to here. Ooh, what does this tool do? Whoa. Okay, anyways. So what do we know about these two lines? Well, we can tell that, oh, we know that this is equal to this is equal to this, and this is equal to this. We also know that this is equal to this is equal to this. Um, this is its own thing, but it's also equal to that since it's vertical angles, right? What else do we know? Hmm. I'm thinking it's something like this, like the squishing action, how you get the top triangle compared to the bottom one. Um, Anyways, let's continue classifying these angles. So, this, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. I don't think I'm getting anywhere. Oh, maybe we could use parallel lines. So these lines are parallel, right? So that means that let's get another trapezoid real quick. Bam. Yeah, I'm just gonna shorten this a little. Yeah, that's good enough. Bam. Bam. So then if we have this transversal, oh, but that's not, darn. I don't think this is gonna work. This is that, all we can tell is that this is equal to this. Can we? Okay, I think that's helpful by a lot. I want to use pencil white just to get rid of this then. Okay, and then just to add this back, what was that bottom corner when that's just a 1? So that's a 1 there. That's a 1 there. So that means that these are similar. Okay, that's good to know. That's good to know. Ooh, we're making progress, I believe. Whoa. Go back in here. Ooh, can I add change? Ooh, you do that with this too? Huh. Okay, anyways, zooming back in to make this like, it was like that big. Yeah, good enough. Whoa, that looks really weird. I need to make it slightly bigger. Okay, that's better. Anyways, no, 3. Yeah, there we go. There we go. That doesn't look weird. Okay, continuing on. So now we know that this is similar to this. So 5, and there's a scale factor, and it goes to here. Okay. Um. So we know that this now, in order to figure out this small thing, the length of the longer base, which is what we're trying to find out, is we need to find, yeah, this compared to this, which we can't do directly. So what we need to do is find these two compared. This red line here, compared to this blue line, or blue line sector. What is it? A line. I haven't been in geometry for a year. I don't remember. Anyways, a line segment. There we go. So yeah, what is this, like law of sines or something? Like I don't. I never learned law of sines. I don't know. what do we know? We know the transversal is 7, so we know that uh, blue or red, no it's not, oh my gosh, I'm not colorblind. Red plus blue is equal to 7. We know that. What else do we know? We just need one more system of equations and that should solve it. Or one more equation in the system to solve it. So we need, hmm, hmm. Maybe we should use this value of 3 here. Because it gave us the 5, we're utilizing the 5 as a scale factor, the 7, the transversal gives us this equation. I'm assuming the 3 will give us one more. What do we need to do with the 3? Let's do another line. Let's continue on with this Noether diagram here. Another line. So, jeez. I like put it here. Okay, so this is just good to know. Do not want to do that. Do not want to do that. Do not want to do that. Okay. What do we know about these angles? We can't say anything about these angles because they're bounded by this line, which is not part of the parallel lines. Can we say anything else though? Well, we know this entire angle. I'll do this in yellow so I remember. Now that this entire angle, or this is green, is equal to this entire angle. So that's the same on both sides, I guess? I don't know. But that really means we could bisect it down the middle and we get the same resulting shape, which would give us, just trying to get rid of this because I don't know. Oh, I could increase the size of my eraser. That's what I can do. Bisect this down the middle. And then we get this. I should use the line tool there. We get this. Which, I don't know. We know, what's the top one? Is it 5, I think? Yeah, so 5, so this is 2.5. This is 0.5 question mark. This is, wait, is that 3.5? No, it's not 3.5. This is blue here. And this is red up here. And then this is 3. So we know that these two, okay, now I should probably get rid of this, get this smaller, just to neaten this up. Darn. Line tool. Line tool. I'm spending a while on this problem. Imagine I don't get it. Oh gosh. Okay, so what can we know about this? We know that wrong tool. This is equal to this. And we know that this is equal to this. This is at a right angle. Oh, we might be getting somewhere. This is at a right angle. Because we just perpendicular, right? We bisected it. Um, okay, what can we tell here? So this is 180 not 180, yeah, it's 180. 180 minus 2 of the double angle. I don't know how I should notate that. Double angle. But does that allow us to find from 2.5 that if we can find this vertical using the stuff we already have, then we could find red, which will allow us to find blue, which will allow us to find question mark. So, wait, will it allow us to find question mark? Yes, it will, because then it'll give us a scale factor. Okay. Um, but what do I do here? Should I bisect this into a 90 degree? That wouldn't do anything, because we don't get any right angles. Yeah, nothing. Um, huh. I mean, that does result in those two being equal, which would result in none of these being equal. I'm gonna undo that. And I'm also gonna get rid of this, because I don't think that's needed. Okay, let's try to find the vertical. Okay. I'm just gonna rewrite the triangle to make the trapezoid to make it easier. Is there a trapezoid tool? No. Ooh, what's this tool? Ooh, interesting. Okay, anyways. Line, bam, bam, line, bam, 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 and then just erase that. Okay, how do I find this vertical right here? Given that this is 2.5 and this is 3. Can I use sign identities or something to find this with these two? Maybe. Um, Anyways, so what is this right here? This is something that I don't think I've notated yet. This is this thing, which I don't even know what that would do. Line here to here. Yeah, is that form a right angle? I'm not sure. It doesn't look like it. Anyways, back down here. We also know that this is 7. Huh. Um, hmm. What if I were to, so I'm just gonna notate, this is a right triangle, and if I were to do this is a right triangle, then that would make this 2.5, that would make this 3, that would make this a square, maybe? No, I don't think that, yeah, it doesn't have to be a square. Um, Hmm. I can ultimately find this value too, and that would lead to question mark. Because this is 5 minus 2 question mark, I think. Yeah. Hmm. What does the diagonal do in particular? Like if I take a trapezoid like this, and I do this, does that bisect this angle? No. What does it do though to the angles? I'm not sure. Okay, anyways, just rewriting some triangle similarities. This is also equal to this. Which means that this is similar to this, which we already know. Do we? Actually? Because this is 2.5. This uh, this is part of the 7. This is, I don't know what that is. This is 2.5 plus something. This is the other part. This is 7 minus. This is 7 minus the other one. And then this is something we don't know, the vertical. And we don't know the vertical where it intersects either, so yeah. Um, can I compose a triangle that doesn't create at least what looks like a square, or sorry, trapezoid. And then I cut this in half, and then bam, 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 bam. Yeah, that seems to not produce a triangle, or square. So this is not equal to this. But I can say with absolute certainty that this is equal to this. So note that that's equal to that. So, yeah. So here we're trying to find x here. X, this is a similar triangle to this, which is a similar triangle to this. But we don't know the... Oh. Oh, we're close. I don't know if I made any progress, but this big triangle has this mini triangle, has this mini triangle. So this big triangle will help us find this. No, it won't. It won't. Here, at least we know the hypotenuse, but we don't know the bottom. We could derive question mark from. The bottom is, we'll call z. So z squared plus vertical squared equals 7, and then that doesn't give us anything. So we just need the vertical now. Vertical is hard to get, I guess. Vertical is really hard to get for someone who doesn't know their equations. Um, Sorry if I'm being quiet, I'm just trying to analyze these equations. I just need a triangle with right triangle, two values I have of the legs or the hypotenuse, and then I could find x or z or the vertical or something. Or just question mark in general. What if I were to expand this triangle? Okay, this is the last triangle, the trapezoid I'm gonna make before I give up. What if I were to expand this trapezoid? Bam, bam. Okay, so what if I were to, ooh, and then in red, I'm gonna add up here. So this is the same angle. What do I know? I know that this is 5, this is 3, this is question mark, and then this is 7. Can I find anything about this triangle that'll help me find something about this triangle? Let's see. Um, well, let's see. If I were to change the lengths of the bases, then this triangle will get bigger and smaller compared to this triangle. So that's something. If I were to bisect this in half, does that give me anything? Well, I know that this is equal to this, which makes this equal to this, which makes this an isosceles triangle, which makes this a right angle, which makes these two similar, which makes these two also similar. I guess this just makes this entire triangle similar, which makes me think that I don't know what I'm doing. Well, I know that this triangle up here is similar to this triangle down. This entire triangle is similar to this triangle up here. Um, I have the base length is 2.5. I don't have the vertical length. Can I find it with sine of something? No, I don't have any of the angles. With this big triangle, I have none of the lengths. With this small triangle, I have one of the lengths. Can I make another triangle somewhere? A right triangle? Um, can I say that any of these are similar? I know that this is similar to that, which is, it's, yep. Um, which makes, I have no idea. The answers to these have to be integers, right? This is obviously positive. If the diagonal is 7, if that diagonal is 7, that makes me think the shorter base is 5, so we know it's between 5 and no, it cannot be longer than 7. Yeah, so I'm gonna guess 6. Wait, can it be longer than 7? 5, and then let's make this like really long. And then bam, bam. How long is the diagonal compared to the bottom? The diagonal is shorter, so it's probably longer than 7. Um, I'm gonna guess something. Because I could also, if I find the ratio between this and this, or something that allows me to derive the diagonal uh, from this and this, I guess. I don't know. F of short, comma long goes to diagonal, and then I have f of I have short is 5, comma long is goes to 7, then I probably can find diagonal, but I do not know the equation. Yeah. I think I'm gonna guess 10. If I were to plug in values for x and check them, or for... Was there an equation that I could derive for? Zoom out. Whoa, look how many things I have. Down here. Actually, I'll do it here. So question mark plus blue must equal 7. So let's... We don't have the vertical either, so I'm guessing 2 values, both question mark and this. So that won't work. Can we do it here? If we were to use vertical things, let's have vertical angles, let's have vertical angles, let's have vertical angles. If I were to do a bam, this is a right angle, this is a right angle. Yeah, no. Well, red and blue are likely integers if they both add up to 7. So red plus red, comma blue are, I don't know if this is the correct notation, they're part of integers, which is n. These natural numbers. And red and blue are obviously positive, they're probably integers. So 2.5 squared plus this part of the height, which I'll call g. G squared is equal to an integer. So that's 2.5 squared is 25 squared, which is, I don't know what 25 squared is. 25 times 25 is equal to 5 times 25, which is 125, plus 20 times 25, which is 1, 0, 0, 0, 0. I did that wrong. It's 5, so it'd be 6.25 plus g squared is equal to blah, blah, blah. So it's g squared goes to blah, 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 0.75 because we're subtracting this. So integer minus 0.25 is equal to 0.75. So what squared equals 0.75? G is an integer, likely, I think. I don't know. Wait, what can't be an integer? What am I talking about? So 1 squared for it'd be a like 10 squared with 10 above 10 squared. 15 squared is not that 6 25 okay. I'm done. I have no idea. I'm gonna check the answers. Wait, first off, I'll guess 10. It was 8. Okay, well, let's look at the solution. dB equals 90, dB/VC. Okay. Okay, I'm gonna have to blur this while I'm constructing, or I don't know. I'll write down the solution. So here is this. This, this, A, B, C, D, E. What do we know? A is 5, BC is 3, DB is 7. We know that this is a right angle, this is a right angle. Anything else? Okay, and they called this x, and this is 5 plus x. They get BE, that's my question. Huh, what are they doing here? 7 minus 5 plus x squared is equal to 3 squared minus x squared. Oh, they are setting up the Pythagorean theorem, but they have it so that this is equal to the diagonal, and then this is equal to the diagonal. So then they just set it equal to each other. That's so smart. I've never seen that before. And then they solve that, and they get x is equal to 8. Great, this is our first one that we haven't solved, but I put a significant amount of time into that. And I'm happy of the critical thinking that came along the way. This is all the work we did. Thank you guys for watching. I'll be back tomorrow, and bye.